Good morning, everyone. Namaskar. My association with Vivekji now goes for nearly 2 decades. I think from his previous college where he was teaching to now where he is. I think we've been together in this journey, and uh, I've been to APJ. I've spent some time there, taken lectures as well as part of the faculty program. So it's good to be addressing all of you again. I was, in fact, I was assigned a topic by Vivekji when he said that why don't you talk on services with respect to integration with the architects and all. So I requested him yesterday. I said, look, there is a decarbonization wave which is sweeping the country, the construction industry, and everywhere. At this point, if we have to talk about the faculty program, it is important that we all get involved in this journey which is happening. The business environment for us here in the industry is changing very fast. We can see, we can feel the pressures which are coming from corporates, which are also coming from the users when they are asking the developers that we want net zero buildings now. In fact, zero has now become a new mantra in our industry. I remember I started talking about the subject zero in 2001 onwards. 2011, I started giving presentations on the topic, and the first presentation that I gave, people said that, look, this is good theoretically, but it's not going to happen. Zero doesn't sound right, whether zero energy, zero water, zero waste. 10 years later, moment our Honorable Prime Minister goes and commits that 2070 India will decarbonize, suddenly zero is booming. In fact, at one of the conferences earlier this year in January, we were speaking to an international rating agency, who does these rating of the buildings. And we said that you have a net zero energy rating system. What is the response like worldwide? So I was amazed to hear when the person mentioned that they are about close to 190 buildings which are registered with them, which are going net zero energy rating, out of which 80 plus come from India. Now look at the numbers that India is clocking in the net zero arena. As part of the Indian Green Building Council, IGBC, I had the opportunity to chair the development of net zero energy rating system. In 2017-18, that rating system was launched. And today, in 2024, we have nearly 200 buildings which are registered on the net zero energy scale out there. Now, mind it, net zero energy buildings are difficult. It doesn't mean it, like if you think that it is only requires putting a renewable energy there and getting the job done is not correct. If you think only engineers can go and achieve that job is not correct. If you think only architects can just do with the building design is not correct, because that's where lies a true integrated design. And this is why I requested Vivek yesterday. I said, I like to talk on decarbonization and net zero buildings, because I feel if as APJ, you prepare yourself for the change that is coming, and that change is not, we're not talking about decade. We're talking in next 2 to 3 years time, the whole industry will change. I said, if you prepare yourself for this change, believe me, you'll be way ahead of what others are doing. Everybody else across the world is talking about it. And it's important that we in India do the same thing here. So I'm going to I'll give a small presentation on the subject, and then happy to take up the questions. I did get some questions which were shared by Vivek yesterday with me. I know a lot of you have questions with respect to the air conditioning. I do HVAC systems design, so I'll be happy to talk about it a little later. But right now, I think let's concentrate on the subject, which is the decarbonization net zero energy buildings. Now, this is, as I say, the changing landscape for construction industry. I'll keep this talk for about maybe 45 minutes. to 1 hour, depending on how it goes. And after that, we can have the question answer session, which you can talk about the subject here, what I've mentioned, or we can even get into the HVAC questions, which some of you have sent across. I'll be happy to address them. So let's go ahead and talk about it. Now, many of you would have heard about COP, and COP 28 is what happened last year at Dubai. And COP is the conference of the parties, and these parties are governments. So each government represents one party, and they all get together at COP to discuss on issues relating to climate change. COP is not new. It started way back in 95 in Berlin, in Germany. And since then, the meaningless COPs have been happening. In fact, many of you who follow the refrigerants would know something called a Kyoto Protocol, which came up in 97, where we started talking about phasing out CFCs, looking at the greenhouse gas emissions, and all of that process started there. Till today, we continue to implement the GHG reductions program, GHG's greenhouse gas reduction program. But in 2021, at COP26 at Glasgow in UK, suddenly the world came together. They realized the importance of climate change, which was sweeping across the world, and they decided to give a commitment to decarbonize. They said each of the country will become a carbon neutral country. And that is where the whole momentum took place. And in India, that year, our Honorable Prime Minister said that 2070 is our target to decarbonize. And since then, I can tell you the entire industry is in a fast track mode to change the way we are doing the things. Now, climate change is not new. It has been around for many years. In fact, 2013, IPCC, Interpanel, this IPCC in 2013 came out with a report which said that they presented 4 scenarios. The first scenario was where they said if you are able to arrest the carbon emission, the temperature rise will be limited to 1.6 degrees centigrade. The second one was that if we let the carbon emissions happen at its own way, the way they are doing currently, the temperature rise would be 5 degrees plus. And then they presented 2 more scenarios in between. It sounded alarming. People started talking about it, but nothing happened at that point of time. Important was that in 2021, when the COP26 happened, everybody said, let's limit the temperature rise to 1.5 degrees centigrade, because if we allow the 1.5 degrees centigrade ceiling to be breached, it can even lead to catastrophic effects in terms of faster melting of the glaciers. It could also be in terms of vanishing flora and fauna from the earth. Today, in 2024, we are at a situation when 1.5 degrees centigrade rise is inevitable. It will happen. It will happen either this year or early next year. That is going to happen. Now everybody is saying let's limit it to 2 degrees centigrade. But the question is, how do we do that? What is it that is causing this global warming? What is it that is leading to climate change? What is it that you and I can do? I think that's what is the important aspect here. India also is no stranger to climate change. The shifting weather patterns, very fact that we don't get our rains anymore in July, we get them in August. Our summers are delayed, our winter are delayed. The entire cycle is shifted. Not only that, the intensity of events, the weather-related events have now become much more severe. We can see the flooding, which happens. Last year was Delhi. Before that had been, in fact, in Pakistan, there were floods and extreme temperature conditions. We touching 50 degrees centigrade here in Delhi. Everything is relating to extreme weather events, which is being attributed to climate change by the scientists. We always hide behind the fact that we are 1.4 billion people. And any number that is presented in the global arena, in terms of the carbon emissions, in terms of the energy consumption, in terms of whatever, we tend to hide behind the fact that we say per capita number should be looked at. Well, any number, if you divide by 1.4 billion, becomes a small number. And that is where we seem to be taking shelter that, look, everything is okay. It is not our problem, it's somebody else's problem. But if you look at our emissions, we are already the third largest emitter in the world in terms of the CO2 emissions. With third largest emitter and our target as 2070 as a decarbonization target, some of us can take it easy and say, how does it matter? 2070 is far away. I'm not going to be around. Even my children are going to be old by that point of time. Technology would have come in at that point. Maybe something would happen, but why should we worry about it? Well, the government has set a very scorching pace in terms of this implementation. If you look at the Panchamrit, which came out at the time when COP26 was announced, our Honorable Prime Minister said two elements which stood out of the Panchamrit was by 2030, 50% of Indian electricity grid would be decarbonized. The second one he said was by 2070, of course, will be net zero carbon emissions. If you look at it, it's a serious commitment. It has come from a country, and it is not like that you give a commitment and don't honor it. In past, India has a good track record of meeting its commitment, whether with respect to CFC phase out, whether it's HCFC phase out. So we are doing our job seriously there. Of course, the scales are mammoth. Today, about 88, the countries who are responsible for 88% of the global carbon emissions or GHG emissions have already committed to decarbonize and meet the targets. So India is one of them. Now, why am I telling you all this story? One, we have to realize you as faculty, myself as a working professional, we are all part of something that we call a construction industry. And construction industry today is growing at a fierce pace and will continue to do so in years to come. The buildings, they account for nearly 35% of the energy consumption at this point of time. Besides that, the buildings are also responsible for nearly 40% of the global carbon emissions that are taking place. Now, mind it, we are one of the largest carbon emitters as a building industry in the world. And there is a commitment to decarbonize by 2070. Now, it is but natural that if that commitment of decarbonization has to be met, the government regulatory bodies will go after first the largest emitters. Who are the largest emitters? One is the automobile, and second are the buildings. Automobiles are already going through a sea change where we are talking of the EVs. The rate at which the EVs are coming in is known to everyone. Two-wheelers, four-wheelers, everything is going EVs now. And on the other hand, building industries where you and I belong, and we are responsible for 40% of global carbon emissions. And I can assure you that the rules, regulations, codes, statutory bodies are changing at this point of time. If this was not enough, the construction industry is all set to grow further. We are talking about India becoming a $7 trillion economy by 2030. A lot of us, we can feel nice about it, and for all of us should feel nice about it. Why not? We become the third largest economy in the world. $7 trillion by 2030. Wow. But are you aware that if the economy has to go up, the construction industry need to go further up? We all like to compare ourselves with China, because China and India at one point of time were around the same GDP numbers. And suddenly China shot up ahead. And you know what was responsible for China's growth as a country? Construction industry. the construction industry contributed to over 30% to the GDP, whereas in India, the contribution is only 10 to 11%. That means if we have to grow like China, if we have to compare ourselves with those economies, we need to construct even furious pace. And mind it, if we construct, we emit carbon emissions because the buildings are responsible for 40% of global carbon emissions. If we construct, we increase the carbon emissions. If we increase the carbon emissions, how do we meet our target of 2070, which is of decarbonization? So it's a very strange situation where we are stuck at this point of time, need to grow, but need to cut down on carbon emissions. Now, these are two things that have to be balanced out. And it is not like our construction industry is going to stay like this. We are forecasted to be the largest construction industry in the world. Not now, till for next 10 years, we'll continue to build. We will build at some of the facts and figures that are coming in. It says we'll build at the rate of 1 Chicago a year. All statistics are continuing to show that India is developing at a high pace. The urbanization is taking place. And as the urbanization happens, more and more buildings are going to get done. I like to believe that the global economy today is being pushed a lot by India because at growing at a rate of 7%, 8%, whereas the world is looking at 1%, 2%, 3%, I think that itself talks about how fast we are growing at right now. Now, what causes this? What are the GHG emissions? How do they lead to the global warming? Where is the building industry responsible? Let's get to the fundamentals of it. I know some of you, or maybe all of you, would know about the subject, but it's important because wherever I have spoken in past, I think I would have spoken on the subject nearly 200 times in last 2 years. And everywhere that I've gone, the fundamentals are still not understood. Unless we understand the fundamentals, how can we address the solution to it? So the GHG emissions are, these are the gases which are being released in the air. Carbon dioxide is considered to be one of them. And it is also taken as a reference. So when the carbon dioxide emissions or the GHG gases, they go into the sky, they sort of linger on in between. When the sun is on the top, that the sun energy comes down, the heat comes down. It always strikes the Earth's surface and bounces back and goes back into the sky. But what is happening is with this GHG gases, greenhouse gases or the carbon dioxide, they form a layer in between and they are trapping the heat which is reflecting from the Earth's surface and not allowing it to go back into the sky. And when this heat is trapped, that is what is leading to rise of temperatures, and this is what we call global warming. Carbon dioxide is one of the greenhouse gases. There are other greenhouse gases like methane, NOx, CFCs, HCFCs, which are nothing but the refrigerants used in the air conditioning system. And that is why the air conditioning is regarded as one of the key areas which has to help towards decarbonization. There is also another term called embodied carbon because we're going to be talking about it. And it's important to understand because these are the areas where you all have to do the research. The entire construction industry is looking at the institutes to come out with the answers in these areas. So we are finding a lot of leading institutions across India, across the globe, are working on the subject of embodied carbon and the issues which are surrounding that. Now, let me explain the term embodied carbon. The embodied carbon is the one where, for in construction industry, we use a lot of materials. Let's take an example of steel. Now, steel has to be first, iron ore has to be extracted from the ground. So when you extract the iron ore from the ground, there is an energy being spent, and that energy is leading to carbon emissions because the energy in India is produced from coal, and coal is not a clean fuel, and it leads to carbon emission. After the extraction of the ore is done, that ore is transported from the mines to the factories. There's again a carbon emission taking place because you are burning fuel. In the factory, we are processing the fuel. We're processing the ore. We are again converting it to steel. While we are doing that, the energy is being spent and carbon emissions are being let out. Then the steel which has been fabricated or which is processed is now transported site. Again, the energy is being sent. Once it is being installed, again the energy is being sent. So all that energy and the associated carbon emission, we started from the point of extraction to the point of consumption. They all are embodied in that material, and that's why it's called embodied carbon. So this is what the embodied carbon is about. If I look at the carbon emissions that take place in our construction industry, we look at two aspects, which is the embodied carbon, which is the materials, and the second is the operational carbon, which is the energy being spent to operate the buildings. Again, as I said, the building energy is a dirty energy because we produce from coal, and that is why the operational carbon is an important aspect. If you look at what the total carbon emissions in the building are, if you see the graph here, right in the beginning, you'll see there is a big spike. That is the embodied carbon. When you construct a building, there's a huge amount of materials you use, and there's an associated embodied carbon. Then the building is running, operating. That is where the operational carbon comes in. There's a midlife renovation which takes place. Again, a huge amount of embodied carbon. Again, the operation, and then finally end of the life when we are demolishing the building. Again, there is a carbon emission associated with that, and there are embodied carbon there. So both embodied and operational carbon are an important aspect. They, in Indian context, could be contributing nearly equal because the amount of material that we are using is huge. Construction that we are doing is huge. And that is why embodied and operational carbons are both important aspects. If you look at the developed country, they have already finished construction. They may not be worried so much about embodied carbon. They are more challenges are with the operational carbon, but in the Indian context, both remain an important subject. If you look at the operational carbon story in India, this is what we are going to be doing. We are, as the global warming is taking place, we are going to be putting more and more air conditioners. In fact, one of the stories that talks about, I'll show that to you. It says, one of the Times of India articles said that by 2037, every 15 seconds, we would be selling an AC here in India. Now, that's a huge number of air conditioners that are coming in. Another newspaper article said that by 2050, the amount of energy that will be used in the air conditioners in India will exceed the total power demand of the entire Africa. Is it progress? Is this what we want to go to? I think this is something that we need to talk about, think about, and worry about. By 2050, nearly 70% of our energy would start going into the buildings. In some form, the commercial, industrial, domestic, it'll start going into the buildings. This is the story of the operational carbon. On embodied carbon, we have not even begun. All we know is that we are going to be constructing, and constructing. And there is nothing that is going to stop us from constructing, because as India is becoming urbanized, as we are becoming developed, and I've shown that to you, the construction will happen. And as the construction happens, both embodied carbon and the operational carbon will go up. As they go up, we are today already the third largest emitter in the world. Believe me, we would not like to take the position of number one here also. So let's be careful what we need to do. The world has now started talking about whole life carbon. They say, forget this embodied and operational carbon business. Carbon is a carbon. Emissions are emissions. Global warming is happening. You can keep hiding behind embodied and operational. A lot of people started doing, a lot of companies, a lot of countries started doing, they started looking at the operational carbon, because that was easier to handle by decarbonizing our grids. That means going more and more renewable energy. The operational carbon could be reduced a lot because you're using clean energy. But then we are not worrying about the embodied carbon. So they started talking about the whole life carbon. Whole life carbon is the sum of embodied and operational carbon. And they came out with this carbon information. Those of you who are interested in this area must read through it. Today, the whole carbon emissions are divided. The cycle is divided into A1 to A3, which is the product stage, which is where the embodied carbon comes in, A4 to A5, which is the construction stage, B1 to B7, which is more about usage, C1 to C4, end of the life, and D is the benefits beyond this boundary. Again, I'm not getting into details because this is a good subject where each one of us should be talking about. Unfortunately, in India, in fact, I can give you a heads up here. A lot of youngsters today are wanting to know about this. While we talk about traditional architecture, traditional engineering, but the world is right now looking at decarbonization. Where are the professionals who are going to guide, handhold the industry when they have a pressures, when there are laws which are requiring them to decarbonize it? And in India, we are not able to find those professionals because in our country we don't have colleges which are producing those professionals. There are no courses which are talking about it. In fact, I also had to my son who's graduated just now and wanted to do more work in that. I was unable to locate colleges who are doing good work in this area in the country. So I think this is another thing which we have to talk. And believe me, there's no special professional is going to come in. It is the architects and the engineers who have to take this role. World is changing, as I said earlier. Already, Europe, which is a leader in this area, has announced policy targets. Every country has come out with a decarbonization target in Europe. EU is far ahead. America is catching up. India, Asia is yet to wake up to this challenge. In fact, Denmark has been hailed as a master in this area. They have come out, and just like you, when you construct a building, you apply for a permit in which you go to the government and say that you want to build the building, and these are the laws to which you will be adhering to. What Denmark requires is they give you a carbon allocation at that point. They say any building in 2023, if you're applying, you will be allowed to have a total carbon emission, whole life carbon emission of 12 kilogram of CO2 emissions per square meter per year. So now you have an allocation in which you need to work. And you have to be balancing your embodied carbon, you have to be balancing your operational carbon. It doesn't matter what you do, you have a carbon allocation to which you have to prove. Now, if that 12 was not enough, they are going to be bringing down that number. And by 2029, your allocation will be, when you make your building in 2029, you'll be allocated 7.5 kg of CO2 emissions per square meters per year. That is all that you'll be allowed. And your buildings will not only have to be energy efficient, they have to monitor, they have to improve, and also your materials will have to be less carbon consuming or carbon emitting. Now, who are the key stakeholders when we talk of this whole life carbon regulation? At the planning stage, architects, again, comes down to you. At the design stage, architects. At the construction stage, again, architects. At the usage stage, yes, the engineers walk in. If you see here, there's the entire process requires architects, engineers, developers, financial institutions, owners, sustainability consultants, everybody to work together. If one of them is a weak link in the whole process, your building can fail. And that is why this is the changing scenario that we are looking at. Imagine if I have this scenario being done in India. You go to Greater Noida Authority, say that you want to build a building. The Greater Noida Authority tells you that your carbon emission for the whole life is not going to exceed 12 kg of CO2 emission per square meter per year. You have to prove it. You have to demonstrate it. How are you going to do that? And if you don't do that, your building can be demolished. Suppose they were to come out with that regulation. At that point, you cannot do the blame game that architect did not do it right, engineer did not do it correct, contractor was wrong, building owners don't know how to do it, operators don't know how to do it. Nothing is going to work because this is what we call a performance-based regime. And that is what we are seeing right now. The construction industry is now shifting to a performance-based regime. In India, this has not yet started. These are early days, but internationally, they are already talking about it. I'll leave this part out for the time being. All I can tell you is while the grid decarbonization is taking place, where more and more renewables we are talking about, you would have heard about our Prime Minister coming out with that in the budget in February when it was presented. Spoke about the rooftop solar, the benefits around it. They are all coming from the fact the statutes are coming around it. At this point, incentivization works. Tomorrow, the penalties are what are going to walk in. The industry is shifting. And as I speak, I keep repeating this word because I'm seeing this in front of me. There is a new term called Industry 4.0, where things like AR, augmented reality, VR, virtual reality, IoT, Internet of Things, big data. You talk to anybody, big data is a word, automation, Internet of Materials, and there are things like AI, artificial intelligence. Everybody's talking about it. We are all sitting at a point where our traditional way of doing the things are being challenged. AI can write a better thesis than many of us can do. That's where the whole situation is. If this be the case, is our traditional way of doing the thing the correct way? Today, there are AI models, and I've seen them with my own eyes, where one of the interior design companies, in fact, uh, they had a software model in which they were doing the guest room design, a hotel guest room design. The hotel guest room design, they had the parameters defined there. That means the toilet has to be this side. There were certain rules defined there, which said that the WC must be given this much of area. Around the bed, you should have this much clearance. They put all the rules, and then they fed in the dimensions of the room, and suddenly the 7 alternates of that room design came out. And it's not possible to get an 8th alternate. The 7 alternates were developed by that software in matter of 5 minutes. We had the 7 options in front of us. Now imagine which architect, interior designer, engineer can produce that. That is the level of automation we are seeing in front of us, and all that is being driven by Industry 4.0 at this point in time. As I said earlier, the performance-based design is here. Internationally, this trend has started where a developer comes to architect or comes to engineer and says, I would like my building to be, let us say, net zero energy. And it should not cross an energy consumption of 100 kilowatt hour per square meter per year. It should not have a carbon emission more than 15 kilograms of CO2 emission per square meter per year. Now, these are performance parameters. You have to meet them. If you don't meet them, your professional indemnities, your professional liabilities are at stake out there. We in India have not worried about the professional liabilities till date. But today, professionals who are practicing carry an insurance. Like my organization, we carry an insurance of 10 crores of rupees, which is also not enough. We are being asked to take insurance worth of hundreds of crores in order to perform in India, because tomorrow, when there is a performance-based design issues come in, and we are sued for building not meeting its performance, who's going to pay for that money out there? Now, we may brush it off, but that's not how it is working here. The performance-based designs are coming. They are coming in very fast. And that's where the integrated design approach comes into the picture, because no more we can do the work the way the work we are doing right now. And that has to start at the faculty level. Wherever I have done a panel discussion on the subject, Wherever I've gone, they say that, look, until unless it starts at the institute, it starts at the college, there is no way this culture is going to come in. And that's where I said in the beginning, the faster we adopt to this changing world, the reality is going to be. The days of L1, which a lot of us in our professional industry stare at that, the days of L1 will go away. It will all be about performance. So it will not only be the price, it will also be the performance which will be a determining criteria. Well, just as the caption here says, you could not have built Taj if Shah Jahan was to ask for 3 quotations and give the work to the lowest contractor there, the lowest price contractor there. Even technologies are going around getting it right the first time. Why? Every time, it's a very normal thing. Like, we go to the site, we find a brickwork standing there, we just say, I don't like it, demolish it. Then there are clashes taking place in the execution. There are many services installed there that are clashing. Oh, let's redo the services. It's been a tradition since the time I have come into the industry in 1990s. I've been seeing this tradition. But every time we redo the wall, every time we redo the execution, there is an energy associated with it. There are carbon emission associated with it. And mind it, if you have a carbon allocation given to you, if you waste away your carbon allocation and rework, that is where the problem will be. So the technologies are now going towards getting it right the first time. BIM is here. It's here not because of clash detection. It's also here because that makes sure that you get it right the first time. Augmented reality, virtual realities are being talked about. Somewhere in interior design industry, they walked in a limited application. But believe me, we are not far away from the days when we'll be walking around the site with our virtual framework and walking to a site and seeing that other drawings and the execution complying with each other. Modular construction is coming in, not because we are not able to find workers. The real reason will be where it will become faster is when you do it at site, you are spending more carbon emission. If you do it at the factory, your carbon emissions are lesser because it's a controlled environment. And that's why the things like modular construction, 3D printing of buildings would become a reality in coming days. And everything would be driven by decarbonization, not by the cheaper manpower issues that we keep complaining about. Even our products that we are going to be using are going to have a carbon label there. Today, you have a nutrition label. You know what is the fat, what is the various ingredients there. You keep declaring it, but believe me, the carbon labeling also is something that is being talked about. Already, Europe has come out with a CBAM, this carbon border adjustment mechanism, where they're saying any product, they in fact came out for the steel at this point of time. They said the steel coming into Europe, if it does not carry a carbon label in terms of what is the embodied carbon there, or what is the EPD, they call it, Environmental Product Declaration, if it doesn't carry that, it will be taxed. And taxation is up to 30% at that point of time. So imagine if you're sending the steel for 100 rupees here, it'll be taxed by 30 rupees, so you can sell it at 130 rupees, thereby taking away your competitiveness of the price that you were thinking. IOM, I leave that out, is going to be staying there. Core stakeholders of the building decarbonization are going to be the architects, engineers, operators, operation and maintenance team, contractors, material manufacturers, developers, the owners, all will have to work together to get into that environment. If you think this is still a joke or is not serious, government has gone ahead and set up an India carbon market where the carbon trading will start happening. So far, the carbon trading was at international markets. Now the government has brought it to its own shores. Bureau of Energy Efficiency has been made the administrator, and very soon you're going to have the carbon trading taking place in India. So if the government comes out with a regulation which says my building will be given this much carbon allocation, and if I'm exceeding those carbon allocations, I'll go and buy the carbon credits from the market. here in India itself. So right now it will start for the major users. Major users are steel, cement, all of those major users will be subjected to this. They will be buying carbon credits, and people like us who are making efficient building would be selling carbon credits. So carbon trading would be starting, and it is going to start right here in India, being driven again by the construction industry. The World Green Building Council has gone and said, and so is the IGBC, Indian Green Building Council, where I'm part of the network. The IGBC has come out with a direction that by 2030, we must aim to convert all our new buildings to be operating at net zero carbon. By 2050, all existing and new buildings should go towards carbon neutrality. So imagine even these rating agencies are working towards it. If that was not enough, there are rating systems available for net zero. The green rating is old. The new is the net zero rating. So there is a net zero energy, net zero water, net zero waste, net zero carbon. And we are talking about the building resiliency. That is another subject that we're talking about. Building resiliency is resiliency against the climate change. Today, we keep hearing about flash floods. We keep hearing about earthquakes. How resilient are our buildings with that? Because more your building is resilient, more sustainable it is, because it is not getting damaged, and it will have a lower carbon emissions also, total carbon emissions. IoT is in, AI is in. It's a matter of time when they come and take over the operations of the building. So both construction and especially the operations of the building would be driven a lot by IoT and AI. The shift has already begun. We can start seeing the changing face. The standards, I do a lot of work with ASHRAE, and it is not like the developed world is all ready for decarbonization, but they're also struggling. US is struggling. They don't have standards and codes which talk about net zero energy buildings. So ASHRAE took that lead, and in last 2 years, they come out with 7 guides on net zero energy buildings, right from embodied carbon to operational carbon to existing building decarbonization to net new building decarbonization to the methods of evaluating the net zero performance and all of this. So codes and standards are all in making. They are being done worldwide. And some point of time, these codes and standards will start converging and will start requiring us to design buildings which comply to them. In India, the ECBC, which has been the Energy Code of India, long energy code always talked about only energy. Energy with respect to lighting, HVAC system, plumbing system, they talked about only energy as an area. But the government realized that energy code is not going to be enough to talk about decarbonization. Last year, Bureau of Energy Efficiency assigned the task to develop a new code which is called ECSBC, Energy Conservation and Sustainable Building Code. In this, if you look at the topics, it is not energy alone. It is traditional topics like building envelope, comfort system, lighting, and electrical are there. But there are new chapters which got added, which is sustainable sites, water management, waste management, building materials, indoor environment, building commissioning, IoT, all of these things have come in. These are all new chapters. Everybody realizes until unless you do an integrated design, until unless you look at whole of the building together, you cannot be looking at a decarbonized world. You cannot be looking at an efficient building. And that is why I'll keep repeating, what we are doing now has to change. National Building Code of India, incidentally, that the ECSBC has gone through. So I had the opportunity to chair. I was the convener for the ECSBC. I had a team of 152 people who worked with me to develop this code, and this code is now handed over to Bureau of Energy Efficiency. They've gone through a public review where the comments came in, and now it has gone to the government for being released. So in next few weeks, you will start hearing about ECSBC. it will supersede ECBC, which was earlier in force. Similarly, National Building Code of India, NBC, the last version came out in 2016. It is up for revision. Currently, it is being revised. Each of the chapter has a convener. I have been made convener for the HVAC section, and we are on a path of completing the writing of the NBC by end of this year, hand it to the government. Hopefully, NBC 2025 would be available to you, where again decarbonization would appear as an agenda there. I'm just going to end my talk with a case study. I had said a 45 minutes to 50 minutes talk, which is what we are aiming for. I'll bring it back to my office only. The reason is it's easier for me to relate it for all of you. The scale is small. Some of you have been here, and those of you not been here, just like Vivekji said, you're welcome to come and visit this office. We created this as an example of architecture, engineering, users, owners all coming together to design a building which could be a showcase. We've always said that the green building or decarbonization, we get a feeling that it is all for the big owners. It is for the large corporate, Tatas, Birlas, Adanis, Ambanis can do this. Maybe the international companies can do it, but you and I are not part of it because we have always considered ourselves to be too small to indulge in this. But you'll be surprised. MSMEs account for nearly 50% of India's turnover. And if the MSMEs their buildings are not adopting this, you and I are not demanding it, whether we are the houses that we stay in or the offices that we work in or the institutes where we go, we don't demand them to be green, then how will the movement is going to start? We don't want this movement to be a top-down movement. We want it to be a bottom-up movement. And again, the education institutes bear the maximum responsibility for doing this. So when we made this building, it's a government allocated plot. You don't have a choice, whatever direction it faces. But we knew the fundamentals of blocking the west, because in our case, the west is a challenge. So what we did that on the west, we put our core, which is the staircases or the elevators or the toilets. The working area, which is in blue that you see there, is all non-heat area because it's falling on the east, south, or the north. When you're doing the design, the architect came out with the first design. The design looked good. It was something that we were happy with. But when we looked at the daylighting quotient, it was only 86% daylit. We said that's not going to work. We looked at the next design, 80% daylit. We said no. We looked at the third design, 84% daylit. We said no. Then finally, we came to a design with 98% daylighting, and that is what we selected. Our starting was the building has to be daylit. We wanted a building like right now where I'm sitting in one of the conference room. I have not seen an artificial light here at all. In fact, in our building, 100% of the areas, including toilets and pantries, work on natural light. The areas where we do not get natural light are stores, which are not regularly occupied at all. Glare, which is again an important aspect, where what happens is there's a lot of glare which comes into the buildings. People and users, to cut down the glare, they will use blinds and they pull down the blinds. The moment you pull down the blinds, it becomes dark inside. And when it becomes dark inside, you switch on the artificial light, your energy consumption goes up, your heat generation goes up, your air conditioning load goes up, your building energy consumption goes up. Everything is wrong. And that's the whole purpose of daylighting is gone. So we looked at the selection of the glass, how much should the selection be, what kind of performance of glass should be there, where should the light shells be, how do we cut down the glare. We looked at all those aspects. Even the artificial light, we said let's plan it in a way that we are using it wherever it's required. So we did models, simulation models, where we demonstrated, or rather where we looked at the light was falling only on the tables and nowhere else. All the areas around it will have what we call a spillover light, but not a direct light. And we brought the energy consumption or the energy allocation to the light down to 0.3 watt per square foot, which is half of the most efficient lighting which is used in our industry. This is a result of it. These artificial lights. We even the air conditioners that we put them at 5 degrees, 5-star rated. The temperature setting in my office is at 27 degrees centigrade. In fact, I'm ready to even show you my thermostat of the air conditioner right now. It is at 27 degrees where I'm working in. And believe me, I'm feeling cold right now. Why? Because with 27 degrees, we have fans which are operating. So we create what we call a wind chill effect. These are fan images of fans actually from our office. And they create a wind chill effect at 27 degrees. With the fans operational, we feel cold. In fact, the beauty of the building is that whenever it's nice outside, like today, it's very nice and cloudy and cool air is blowing. A lot of areas of our office, they've just opened the windows. We got the clean air just sweeping through the building and only fans are running. We're not even running the air conditioners in some of the rooms. So this is what we call a mixed mode ventilation, depending on how the weather is. In fact, 6 months in the year in Delhi, you have a fair weather situation. In our office, on October 1, we switch off the ACs. And April 1, we switch on the ACs. So from 1st October till 31st March, there are no ACs which are working at all. We either run on fans or we just run with the windows open. That's all. And 6 months, no air conditioners, not only give me a lower electricity bill, but lower carbon emission. We monitor our building. IoT system is there. It tells me how much energy consumption is taking place where. We do mapping. Everything what we use is monitored. And then we give that information to our guard, a security guard who's operating the building. So we don't have a professional operator. A security guard is able to do that. So this is the kind of floor that we could create. You can see the daylight penetrating. You can see the fans right on the top and the air conditioners there, and 100% daylit building. In fact, we don't even have blinds. So if you see go back to the area, there are no blinds on the windows at all. The only place we have put the blind, if you see image on the right, there are 4 workstations where we predicted right in the beginning that there will be some glare. So we have these blinds which are up to a certain height, they come down so that we are able to stop the glare then and there itself. And you can see the all daylit windows, all daylit areas, spaces, and including the fans which are sitting there. The building got its platinum rating from IGBC. It came by virtue of design, not by virtue of spending money, buying the green points. It came purely by virtue of design. When we mapped our first year results in 2022, we were performing 11% better than the 5-star label building of Bureau of Energy Efficiency. The EPI, the Energy Performance Index given by BE, is 100 kilowatt hour per square meter per year. We were performing at 89 at that point in time. We went further. We said that's not enough. In fact, CII gave us an award of a most energy efficient building. We started measuring our carbon emissions. So we measured what we call a scope 1, scope 2, scope 3 emissions. And we started measuring them. We put them in the public domain, and we even signed an international charter called SBTI, Science-Based Target Initiative, where we said that we will cut down our carbon emissions by 42% by 2030. So we even gave a public commitment to that. All our work is put on the website for people to see. We publicly declare it. In the second year, when we did our energy monitoring, we found that we have cut down our carbon emissions even further because that is what the target was. We increased our solar footprint. We reduced the energy consumption. We even changed the air conditioners. We were using what we call split units and all earlier. Now we started using chillers, chilled water systems. So baby chillers of 9 tons were installed, and they are ones which are operating the building at this point of time. We found in our second year, we became 25% better than 5-star labeled building of Bureau of Energy Efficiency. Our energy consumption keeps coming down. And I'm not only a happy owner from a lower energy perspective, but also we were able to demonstrate that if you do a right integration of architecture and engineering, It can help you to cut down carbon emission. It can help you to decarbonize. It can help you to make an integrated design. International Finance Corporation came to us, IFC, and they have a certification called EDGE, EDGE, EDGE. And when they looked at it, they said, no, you're not EDGE, you're EDGE Advanced, which is equal to platinum of theirs, where they said that you are more than 40% better than the benchmark that we have for our building performance. You're 40% better than that. So we got an EDGE Advanced certification. So we also joined what we call a global network for zero, where we are promoting now the net zero buildings because that is what is going to be the future. So, and what I like to say is, I'll just finish it off here. I think we need to be now starting, the education institutions have to take over their role. We keep talking about the earth will come to an end or the challenges that are coming here, but there is nobody there to address it. It can only be done if if we are producing students who are more sensitive, who understand the subject, who understand what needs to be done. They have to be ready for the new India which is coming in. We cannot stop the development. We cannot say that, look, go back to doing ground plus one buildings. That's not going to happen. The tall buildings are here to stay. 200-meter tall, 300-meter tall. 200 is a norm nowadays. In Hyderabad, in Mumbai, in Delhi also 150 to 200-meter tall buildings are coming up. It's a norm. With this new India, I think, and we have to also be aware of the digital that is happening. The AI, IoT, decarbonization, all these will remain there. We have to go back and look at the fundamentals of design. We have to think of the new business ideas. That means colleges have to equip the youngsters to be ready with them, because carbon neutral world will require mindset change, not only how we design, but how we design, construct, and operate our buildings. And it is not going to be just architects, just engineers, just owners, just contractors, just material suppliers. It will be an integrated world with more and more performance-based designs coming in. So I'll end here and happy to take up the subject and questions that are going to be coming at this time. So Vivekji, over to you.
Yeah, thank you so much, Mr. Rakheja. I think it's been an eye-opener. I mean, every time I hear you or I talk to you in person, there's so much knowledge to gain from you. And I'm sure a lot of our faculty who are were attending this presentation for the first time would have really felt the same, would echo the same.